Hi everyone, let's start lecture 3, which is about forecasting, and it's chapter 2 of the textbook. And this chapter will be covered in 2 sections and 2 weeks. So this is section 1 for the first week, and this section will be covered in 3 pre-recorded videos. So this is the first part of the videos. On the course map, we are done on inventory control models. And as you remember, in inventory control models, we assume that we know the future demand with certainty or with uncertainty by assuming a distribution, right? But we know that in the real world, we need to forecast future demand, right? So this is why we do have chapter 2 of the textbook or lecture 3 here as forecasting. So in this lecture or this chapter, we're going to learn how we can forecast future demand. Okay. In section 1, at first we'll have an introduction to forecasting, and then we'll see what kind of methods do we have for forecasting, and then we'll learn how we can evaluate the performance of any forecasting method. So we'll have measures here in order to evaluate the performance of any forecasting method. And then we'll start the forecasting models, and at first we'll have the forecasting models for stationary time series, and we'll learn 2 methods here, which are moving average and exponential smoothing. Okay. So forecasting plays a central role in the operations planning in any firm, because without having forecasts on future demand, how can we prepare a plan for future, right? So this is why we need to forecast the future demand. So these are the examples of forecasting that usually we need in any business planning. Sales of existing and new products. So yeah, we need to forecast the sale of existing and new products. We need to forecast the requirements and availabilities of raw material. Yeah, we need to forecast the changing scales of workers in the future. We need to forecast the interest rates in the future years. We need to forecast the capacity requirements, right? And also we need to forecast international politics in order to do our strategic planning for future, right? So these are examples for the forecasting that we need to have in any firm to plan for future. But in this course, we are going to just focus on the sales forecasting or demand forecasting for future. Okay. Usually the forecasting will be prepared by the marketing department, and then the production department or production planning will use those forecasts in preparing the production plan for future. And we know that a good forecasting will provide benefits for the firm, because a firm can get prepared for future by anticipating the changes and the volume in the future. But uh, poor forecasting will cause significant price for firm, because firm cannot be ready for changes in the future. As I said before, in this course, we're going to focus on the forecasting product demand. And we know that demand is more likely a random variable in the real world. So yeah, by assuming a random variable for demand, we will estimate or forecast its parameters like mean and standard deviation by the past observations or historical data. And we know that some portions of demand may not be predictable. So yeah, we're going to focus on those parts that are predictable, and we will do that by historical data. And also we know that trends, cycles, and also seasonal variation may be present and they may have impact on the future forecast. So because of that, we will have different methods here, and each method will have uh, some characteristics that will consider these issues. I mean, trends or cycles or seasonal variations. Okay, and so the forecasting methods that we are going to have in this course and in this chapter will consider a time series, and we will consider or we will assume past observations or historical data, and based on that, we will estimate or forecast future. Okay. Forecasting can be done in three time horizons: short term for days or weeks, intermediate for weeks or month, and long term for month or years. And these are the examples for these three time horizons. For short term, for example, we can forecast a shift schedule or resource requirements, and intermediate could be labor needs or resource requirements, and long-term capacity needs for long-term, and also sales patterns or uh, growth trends. Okay. Let's see what are the characteristics of forecast. The first thing is they are usually wrong. This means that we need to be prepared for any unanticipated forecast errors. So yeah, we need to have somehow a robust approach and to be prepared for any risks and any anticipated forecast errors. Okay. And a good forecast is more than a single number. This means that beside having a single number for demand of a future year, we need to have an estimate about its error. So by having that, we can see how reliable is that forecast. And the aggregate forecasts are usually more accurate. This means that when we aggregate forecasting of several parameters, then uh, the aggregate error will be less than the sum of the error of those parameters, because in aggregation they are somehow covering their uh, errors. Okay, and the longer the forecast horizon, the less accurate the forecast will be. Yeah, it totally makes sense. And forecast should not be used to the exclusion of known information. This means that if we have several information about that parameter, but we can't include all those information in our forecasting method, then we need to manually include those information and adjust our forecasting values. Okay. In top level, we have two general forecasting methods: subjective and objective. In subjective, we're not going to use historical data, and instead we will have a jury of executive or experts, and the forecasting will be made based on their judgment. For example, sales force composites or customer surveys are the examples of forecasting by this method. And one of the most well-known methods here is the Delphi method. And in objective, we will use historical data. So the forecasting is made based on the analysis of data, and we do have two categories of methods here: causal methods and time series methods. Okay, and in this course, in this chapter, we're going to consider just the objective methods, and we'll learn the causal and time series methods in this chapter. In the causal models, usually we have several independent variables, and the value of those variables have impact on the value of the variable that we're going to forecast its value in the future. Usually we consider the forecasted variable as y, or response variable, and the independent variables are shown here by x1, x2 up to xn, and we will have a relationship between the independent variable and the dependent variable, which is our forecasted variable. So y should be represented as a function of the independent variables, and a typical function here is a linear one like this. For example, let's have an example here. For example, we are interested in forecasting the number of homes can be sold in a typical year based on the interest rate in the previous year. So to do so, we'll have a, a model like this, yt, the number of homes sold at year t will be a linear function, let's say alpha 0 plus alpha 1 x t minus 1. So by this, we are building a linear function between the interest rate in the previous year and the number of homes that can be sold at this year. And so by having the interest rate of any year, we can forecast the number of homes that can be sold in the next year by this model. Okay, so this is called a causal model. But in time series models, we don't have a collection of independent variables. So here we just have a collection of past values of our variable that we are going to forecast its value in the future. So we just have a series of the data, the value of that variable in the past, and based on that we will forecast its future value. And this method is also called a naive method. Okay, so in any time series, I mean any series of data, we may have some sort of patterns. The pattern could be like a trend. If we see a trend in the past data, so we may consider that trend in the future as well. Or we may have a seasonality here, seasonality pattern, or cycles, or randomness. So let's show these patterns in the next slide in the figures. So as you see here, in the first one, we don't see any pattern in the data, right? So we say that here is purely a random variable. So yeah, I mean, since there is no particular pattern, so we consider this as a random case. But in this example, we easily see an increasing trend in the data, and it can be modeled as a linear function. But here we see actually an increasing trend, but it's not linear, so we can consider this as a quadratic or exponential relationship between the time and the demand here. And in this figure, we see a trend. So there's a trend, increasing trend, but we see some sort of a cycles impact or seasonal impact. Yeah, as you see here, it goes up and then it drops to a certain value, and then again it starts to rise, and this pattern is repeated every, let's say, cycle or every season. So in our time series model that we will have the next parts, and in section 2, if we have this kind of seasonality or trend in our data, at first we need to isolate these patterns and then make our forecast, and then we will include the seasonal impact on the forecasted value. Okay, so we'll see these models in the next parts and section 2. Okay, thank you.